Next up, we have Felix, who's going to talk to us about a story of failure during the pandemic.
Okay, thanks. So I just want to share a small story what I did during the last year after the conference was cancelled. It's a story of failure, or perhaps not, during the pandemic. So it was last March 2020. There were reports that worldwide there were not enough ventilators available. And in Germany there was a hackathon, and the idea was to create ventilators based on anesthesia bags. So what was the idea? The idea was to have some kind of mechanical device that replaces human and operates on this bag. And at the beginning, there were about 300 volunteers over all Germany, and we started doing a specification analysis for medical devices, which is quite complicated. And we did risk analysis for mechanical, electronic, software, and usage, etc., of failures, because otherwise nobody would use it. And then I came up with an architecture for this complete system. So we used Raspberry 4 for this, additional microcontroller, which should then drive the motor drivers and the engine for this. Then some sensors should be attached, and everything should be used via a 7-inch display. And these are some very bad pictures of a very old prototype. On the left side, there's an Arduino as a microcontroller, and on the right side is a Raspberry Pi. That's just at the moment running a simulation of an respiration. And the Raspberry Pi is mounted below the display. So then during the time, we had some challenges. So the group has shrunken from about more than 300 to 50 members. And stress tests have shown that the anesthesia bags failed because of mechanical reasons. So they were not able to expand after a certain time. So, but still we had to get the air and the O2 into the human. So one group looked for piston pumps, and the other one looked for a tubing design. The very first design failed because it did not produce enough air pressure. Then I started to doing a next design. So we have a motor, we have a base of the chassis, we have the tubing wheel, and the top of the chassis, and we printed this, and we did a certain amount of experiments with this, and it turned out that the tubing wheel disassembled, or it crashed itself when we came off for a longer time of more than 30,000 RPM. So beside this, we had to create some kind of controller for this motor, because all the low-cost controller failed, even the current was within their specs. So, but there was an open source controller on GitHub. We manufactured the PCBs, and then I soldered them, and I grilled the first motor controller, and meanwhile, it was July. And the world was actually not short on ventilators, but the world was short on medical technical assistants and nurses to operate the ventilators. And that was the point for me to leave the project. So after around about 300 hours, I put over 3 months on the project. What is the loss of time? No, I think not. I recovered that it makes great fun to experiment with microcontrollers. And with such restricted resources, it's very easy to get a system that continuously reboots if you just have too many debug statements in your code. And there are great resources on that for you to look further. For instance, modem.io, which is a great library, and it's a C++ 17-based abstraction on different families of microcontrollers and peripherals that ensure that you use the I/O pins correctly during compile time, not during runtime. And what I learned more, I learned how to help to build me a GPS-steered lawnmower, which is now being used in our garden. Thank you very much.
That's wonderful. Thank you so much. It's really interesting to hear these stories of ingenuity during the pandemic as well. So it's really great to hear. Thank you. How does the Pope pay for things on eBay? He uses his PayPal account.